Hello, everyone. You see the title already. So this is basically about explanations in machine learning. So we have here, for example, a bank that has a classifier. We can consider it to be a black box classifier, for example, and then there is an entity, a client that is requesting a loan, and the classifier answers no. In this case, we would like to find explanation for these answers, but let me say a bit more about the kind of entities we are dealing with. An entity is going to be represented as a record of values for certain features like name, age, income, something like this. Yeah, it's a record of feature values. Yeah. And the idea is to try to find explanation in terms of identifying what are the feature values that are most relevant for the classification outcome, in this case, the no label. Yeah? Or what is the contribution of each feature value to the outcome? That is the idea. That is the problem we're trying to deal with. And we can apply actual causality, as we already saw in the previous long presentation by Joe Halpern. It is based on counterfactual interventions. It's basically, there are hypothetical changes of values in a causal model to detect other changes, right? And they are of the kind, what would happen if we change something, and then by so doing, we identify actual causes. Yeah. The question here in our setting is, do changes of feature values make the label change to yes? I mean, to approve the loan. Yeah, that is the idea. And there is an associated quantitative notion of responsibility associated to actual causality. It's a measure of causal contribution that was introduced by Chocolate and Halpern a bit later than the paper by Halpern and Per. And also there are other attribution scores like SHAP that has become quite popular in machine learning, classification, explanation. But to fix ideas, we're going to concentrate on responsibility. And I'm going to give just the gist here at this point. So again, we have the bank, the classifier, the no classification, the client represented by this record. And then we could consider counterfactual versions that are based on changes of feature values. For example, if we change the age from 18 to 25, we get the label yes. If we change simultaneously the salary to 80K and we move the client from Harlem to Brooklyn, we get the label yes as well. Yeah. So in this case, we say that age is a counterfactual cause because changing it alone changes the label. Yeah. And the responsibility in this case would be 1, whereas the income here is an actual cost because it needs some company, an additional change to change the label. So in this case, responsibility, explanatory responsibility would be 1/2. This is the idea. And the other thing is that still, this is maybe a better explanation. However, maybe this one is an actual explanation in the sense that we can do something, right? We cannot suddenly, if we are 18, suddenly become 25, right? I mean, so maybe raising the salary by 10K is feasible, the same as moving from one neighborhood to another, right? So this is also important to take into account because we might want to reason, for example, about actionable explanations. Okay, these are actionable explanations. We can do something about that. So we need to, let me sell the need for reasoning. So human beings or intelligent systems, they receive attribution scores, responsibility score, for example, as counterfactual explanations and counterfactual explanation, and possibly many numbers as a scores for feature values in entities. And what do we do with them? Well, what does the user does with it? So there is much to be done on process, including reasoning, right? That's the point. I mean, we need to process those explanations, those scores. So we might think of interacting with the attribution score model or algorithm for further exploration. And this could be done by means of logical reasoning. That is what I want the point here. So including a specification of counterfactual interventions, and we want to reason about those counterfactual explanations and about explanations in general. We want to compute as well responsibility scores as a part of a single framework and explanation from the specification. Yeah. So there are many questions. Actually, they become queries. I mean, technically speaking, and reasoning behind. For example, some questions or queries. Are there any other high score feature values that are actionable, right, as I mentioned before, or a specification of actionable counterfactual entities. I want to specify those that are actionable. We want to compute only them, so as other of interest that may appear. I mean, so do I get the same score with a different machine learning system? That is also a natural question to ask and reason about. Or these other attributes score definition or algorithm, right? I mean, not only changing the machine learning system, but also a different attribution score. For example, moving from REST to SHAP, yeah? Or what about imposing conditions on counterfactuals, right? What if I leave some feature values fixed? Do I get the same high score feature with this similar entity, similarity that could be specified, yeah? In a specification we are going to reason with, right? Or is there a high score counterfactual version of the entity that changes this specific feature, right? So I want to change this one in particular. I'm going to find an explanation that way. Or should I, what if I keep this feature value fixed? I'm not allowed to change it. I don't want to change it at all. Are I'm going to find high responsibility or high score explanation? Why do I get this high score for this feature value? And now that it takes us to a higher level, I mean, of why? Why am I getting this answer to my previous why? Yeah, so there are many things that have to do with reasoning. That's the point I want to make and the message I want to convey. So we have used answer programming for logical specifications and reasoning from them. It's a joint work with Gabriela Reyes, was presented last week at this conference. So actually answer programming turns out to be quite useful and natural. It has different properties that are particularly relevant here. There is a declarative language and reasoning via query answering. Possible several answer sets or models that represent different explanations. Yeah, the minimality of answer sets or models and closed world assumption comes very, very handy in this case, because I mean there is this non-monotonic property or common sense reasoning property that allows us to capture persistence. If I want to change this value, I don't want maybe this other value to change suddenly, right? I want to count on that other value to stay as it was. Or program constraints that are particularly relevant to impose constraints. For example, I don't want this to change, right? I mean, and also the language has the required expressive power and computational complexity, and that can be proved. And in a previous paper, I proved that we need this high complexity, right? And there is also a bunch of extensions that are quite handy, like weak constraints. I'm going to mention that, set and numerical aggregations, interaction with external programs or classifiers. Okay, so the responsibility score that I introduced by means of an example very informally is a very simplified version, but I think I don't have to go through all the details. The idea is the following. I have this entity here. I get the label 1. I want to change it to 0, right? So in the end, if I change x to x prime, maybe alone, I'm not going to change 1 into 0, but I need to change other values, right? So these values would be contingency values for the original value that I'm changing. So basically, I have here a counterfactual version of the original entity that gets label 0. I have to change this value, but in addition to this change, I have to make other changes. Yeah. So this basically, in the end, what I want is I measure the responsibility of this feature value here, x, as 1 over 1 plus the cardinality of the minimum size contingency set of y. In this case, the contingency set would be 4 by 2. So basically, the cardinality would be here 2. So it would be 1 plus 2 here. So that's that idea. I have to choose a minimum size contingency set that accompanies the feature value in which I am concentrated. I am changing to change the label as well. Now, this is the idea. So it's a definition that is based on responsibility score as introduced by Chokler and Halper. So we are usually interested in maximum responsibility feature values, yeah, associated to minimum cardinality contingency set of feature values, the smallest gammas I mentioned before. Sometimes we may be interested in the minimal contingency sets under set inclusion for non-maximum responsibility feature values, because we want to compute scores for all possible feature values, right? So the two things are relevant, maximum responsibility or responsibility possibly non-maximum. For non-binary features, rest has to be extended a bit and it can express as expected value, but I'm not going into that. I have done that in a previous paper. I just want to stay on the binary case, so to say. Yeah? So reasoning about counterfactual interventions, I mean, we want to reason in answer programming about counterfactuals in interaction with the classifier. And the classifier could be specified inside the program or invoked as an external predicate. Yeah, so here I'm just going to illustrate things at the light of a decision trees. If you go to this paper I presented last week, you can find a full example with naive Bayes classifier. Yeah. Why this is useful here? Because we can easily impose semantic constraints on counterfactuals. So basically, every counterfactual version leads to a new label, leading to a new label correspond to an answer set to a model. Yeah, so I might have several explanations. And scores, responsibility scores in this case, can be computed by means of a set and numerical aggregation that are very useful and are provided by systems like, for example, DLD, the one that have been used for years. And this is useful for minimal and minimum contingency sets, both. Reasoning is enabled by cautious and brave query answering, depending on what you want to do. Cautious means you obtain what is true in all the models, and brave reasoning is about detecting what is true in at least some model. Depending on the reasoning task, you might want to use one or the other. Yeah, I hope I will have time to present a couple of examples. Basically, I'm using answer set programs, as I said. They have annotations. I mean, and then basically the programs are going to specify the domains. The classifier in this case is specifying the program, and then what is most important here is the counterfactual rule. So basically, I have what I have here. I have an entity that is classified by 1. I want to change the label from 1 to 0. Basically, I pick values deterministically from the domains of those features, and then I change the values in a disjunctive head that in this case has basically 3 arguments, and I change one of them at a time, and that's why I have a disjunctive rule here. And then the deterministic choice can be specified separately. That is something standard. So basically, I'm using this non-deterministic choice operator. Yeah. Then what is relevant here? I want to get rid of the models with unchanged label. That can be done by means of a program constraint that deletes unintended models. Yeah. I define when I have to stop here. I stop when I get the label 0. Basically, that's specified in this way. And then we have to, this important part, in order to compute the scores, you collect the changes, you identify the changes that you have made in feature values, and then that can be used, this is the main part here, for the responsibility score. You compute the responsibility score basically by counting the number of changes, and for that you use these aggregations that are provided by DLD, for example. Right? And then there are, for example, here we have 2 models that are provided by the system. They're not necessarily equally good. So we might, for example, the first one, only the first one, is a minimum counterfactual version because we get a responsibility of 1. In this case, you have a half. We are computing the inverse of the responsibility. So we want only maximum responsibility counterfactual versions. Basically this one. Well, in that case, you have to do is introduce weak constraints that basically minimize the number of changes. Yeah, so you can use weak constraints. They can be violated, but in a minimum number of times. So this is very handy, particularly useful. So only the first model is going to be kept. Yeah, and then basically I'm finishing with this. You can pose different kind of queries to the system. For example, under the cautious and brave semantics, you can ask, for example, give me the responsibility of feature outlook, or a counterfactual version with less than 3 changes. All this can be obtained by means of the brave semantics, and these are the queries. or give me, is there an intervened entity with combination of sunny outlook and a strong wind and its label, or is it true that all intervened entities that give me all the intervened entities that obtain the label no? I mean, they never changed they changed the label. You can also pose this as a query to the program. Or does the wind not change under every counterfactual version? In this case, you are talking about all the possible explanations that you can answer that query under the cautious semantics. So, and also very, very important to point out, that is an important message to send, is you can easily add domain knowledge, yeah, to capture the semantics of your application. So in a particular domain, there may be never, you will never find rain and a strong wind. You discard that model, and basically that can be obtained by imposing a program constraint that delete such a possibility from the model. Basically, that is what I wanted to convey, the final remarks about the importance of semantic and domain knowledge. Right? Reasoning about general scores and explanations is what intelligence do, and explanations are the basis of at the base of fairness and bias analysis. So my point is that you can use this machinery, this scenario specification and reasoning for reasoning about fairness and bias as well. Yeah, but I think I'm going to stop here.